The first thing I want to introduce you to is called the thermohaline conveyor belt. Thermo means heat or temperature. Haline means halogen or halite, which is the mineral name for salt. So this is literally the temperature salt currents that occur in the oceans. You can see that these ocean currents are a giant loop. So a drop of water hypothetically could make it from one point all the way around this conveyor belt and end up back where it started. The currents are driven by wind that moves across the surface of the ocean. That's actually going to be the most important factor we look at today. They're driven by temperature. And this is important because it causes what we call upwelling. When water warms up, it rises, just like air. And when it cools, it sinks. And we know why that happens. That's density, right? So temperature helps drive this cycle as well at places where it upwells and sinks, just like a convection cycle in the mantle. And finally, it's driven by salinity. Salinity is another way to say salt. So we've got halite and saline, and they both mean salt. And the reason that saltiness can drive the current is the same reason that temperature can. When you add salt water, or when you add salt to water, it becomes more dense, so it sinks. So two of the three factors there are density. We're going to talk mostly today about right over on this side, the Pacific Ocean. It's such a dominant feature on our planet that it really does control most of our weather. Most of our weather is controlled by what's happening in the Pacific Ocean. Just like most of the tectonics is controlled by the Ring of Fire around the Pacific. That's a pretty important area in terms of earth science. You've probably heard of El Nino before. Most people don't have any clue what it actually is, but they know it has something to do with the weather. First of all, it's called El Nino because when we first discovered it, the people who noticed it were mostly sailors and fishermen off the coast of Peru, down in South America. And they noticed that it usually showed up around the Christians' Christmas. And so it's called El Nino for the child, the baby, the Christ child. It's the southern oscillation because you can see it's dominant in the South Pacific. Well, it turns out that the top layers of the Pacific Ocean heat up on the eastern side, when normally, due to thermohaline conveyor belt, that side is cold. And that heating temperature can completely reverse the trade winds. And that's a huge deal. Think if our winds in the United States that always come from the west, think if all of a sudden they just totally came from the east instead. All of our weather moved the opposite direction. It would absolutely change where fertile farmland occurs and where deserts occur, and areas would go through droughts that are normally very wet. So everything switches direction, causing major disruptions to biomes. El Ninos can flex between every 2 to 7 years, it seems. And we also don't know if it's going to be a strong or weak El Nino. What we mean by that is if it heats up a lot, a huge temperature difference, then it's a strong El Nino. If it only heats up a little, a degree or two, then it's what we call a weak El Nino. La Nina is the opposite of El Nino. So the western side becomes excessively hot. Now, what they might ask you on the AP exam is, well, what does it actually do to our weather? Okay, well, there's always think about where you live first. If they ask you on an FRQ question to say something about an environmental effect, give them a real life example from where you live. So in El Nino, just think of the opposite. We expect in the Midwest to get snow and ice in the wintertime. But during an El Nino year, we don't. It becomes very dry. The years that we have almost no snow during the winter are El Nino years. And you can see it's warmer. And look at La Nina, it's the opposite. So during La Nina years, we expect a wet, cold winter because that's what we're supposed to get. And if that Western Pacific heats up a lot, we have a very bad winter. Guess which one we're in right now, El Nino or La Nina? Well, what's happening in California and the West? It's very dry out there, which is why we're having the big fire problems. What's happening in the Atlantic Ocean? Hurricanes. We expect a lot of hurricanes because the trade winds are blowing the way they're supposed to. They're pushing all that Atlantic air toward the Gulf of Mexico. During El Nino years, they push those hurricanes away. During El Nino years, we actually have less hurricanes and weaker hurricanes. But we're seeing strong hurricanes this year because of La Nina, the trade winds doing what they're supposed to. These are the patterns that we see of El Ninos and La Ninas. And you can see that it's pretty irregular. We've had some very big events in 97 and 98. Climatologists called this the weather event of the century. And we saw massive droughts in places like Africa. We talked about tragedy of the commons, and there was a big drought in the early 70s. And that's what killed all those cattle. That was El Nino that did that. This El Nino event right here. Now you can see currently in 2020, we have definitely entered La Nina. So we're going to see dry continue out west, strong hurricanes continue late into the season, and we are predicting a wetter, colder winter than normal this year. So if you like sledding, that's good news. And so that warm, moist air comes off of the Pacific Ocean, and it hits the mountain ranges, the Cascades, the Sierra Nevadas, the Rockies. And as that air rises, it cools. See the temperature drop in the bottom diagram? That's Celsius, but that's a big drop from top and bottom of the mountain. When the air cools, it can't hold as much moisture. Remember, humid days in the summer is when it's hot. But when it's cold, the air is dry. So it rains a ton, all on that one side of the mountain. And the air comes over the top of the mountain and it expands, right? It becomes less dense and it heats up and it can hold more moisture. So it's very dry on the leeward side of the mountain. That's called a rain shadow because there's a shadow where they get no rain. And it all has to do with the change in elevation. The cooling air dumps all the water on one side of the mountain. And I'm going to show you on a world map in just a second, but there's a desert in Chile on the other side of the Andes Mountains. They're very steep mountains. The trade winds come from the east. It rains down on the Amazon rainforest. But on the other side of the Andes, there's a skinny little desert on the coast that's completely in the rain shadow. Really what we've been talking about this entire unit, except for plate tectonics. I don't know why they threw that in there. Everything we've been talking about, and even volcanoes would tie in because they could block out the sun. We've been talking about climate. What is climate? And the things that affect climate. Because what we're trying to get to is climate change. Now, you have to understand that climate is just the weather. That's all it really is. It's the weather, but it's averaged, right? The weather changes every day, in Indiana, sometimes every 2 minutes. 80 degrees and half hour later it's 40 out. So we take yearly averages, and in the terms of climate, we look at 30-year chunks at a time. I would know that number. Climate is 30 years worth of averages. Now, there's a second thing you need to know about climate, and we're going to keep it really simple. I want to go to Hawaii. I booked my flight. So the night before, I'm packing my suitcase. I hop on the phone to see the weather in Hawaii. What two numbers do I want to know? What do I want to know if I'm packing to go to Hawaii?
Temperature and humidity?
Yes. I want to know how hot it's going to be. Do I need to bring a sweatshirt or a t-shirt's fine? And I want to know, you said humidity, but I'm going to use the word precipitation. Is it going to rain? Right? Am I going to be stuck in my hotel the whole time? Do I need to bring an umbrella? That's what you want to know. There's so many things we could study about weather. air masses and air pressure and specific humidity and relative humidity. Who cares? Look out your window. Is it hot or cold? And is it wet or dry? That's climate, right? Climate, two things. And you can see the big maps I have on here, average temperature and average rainfall. Okay, so climate is 30 years of those numbers, temperature and precipitation. Now, there are 4 things that can affect either temperature and or precipitation. And those 4 things are listed here. And we've covered all of them now. Latitude, right? If you look at the top picture, the middle of the Earth is hotter because those are the middle latitudes. They're getting the most direct sunlight, insolation. The wind belts help drive our storm systems. Look at the bottom picture. Notice how the southern hemisphere, you've got a thick band of green, and then the lower you go, you've got yellow and then red, and it's like stripes. Those are the invisible stripes. But you look at the northern hemisphere, and it's more chunky, it's more torn up. That's because of differential heating. More land in the northern hemisphere gives us not as smooth of a pattern. Things are much more constant and steady in the south because of all the water. Altitude. Obviously, we just talked about going up a mountain and it gets colder. So areas that are mountainous are going to have lower temperatures. And finally, topography, which is what we just covered, rain shadow, windward, leeward. You can see rainfall down in the bottom picture. You can see that Chilean desert, right? So the trade winds come across right here, and they bring all that Atlantic moisture to bring rain to the rainforest, the Amazon. And then you've got the Andes Mountains, and you see this dry patch right here. That's the Chilean desert on the coast. We see the dry parts of North America because of the prevailing winds in the Rocky Mountains. It's wet on the coast, mountains, dry, rain shadow.